And we are live at Redefine Tomorrow 2022. Hi, everyone. I'm Shi Khai, General Partner and COO at LongHash Ventures. And I'm so excited to be moderating the segment on bridging the crypto future with Axelar. And of course, we have with us Sergey from Axelar. Hello.
Hey, everyone. Great to be here.
All right. Let's jump right into it because our time is fairly limited. So, Sergey, would you like to just kick us off with a very quick one-liner overall intro on Axelar itself?
Yeah, so Axelar delivers secure cross-chain communication, right? At the very high level, what we're trying to solve is the problem of connectivity across multiple blockchains and applications. Currently, they're all fragmented, and we're trying to connect them and unify it together in a simple experience for the users.
Awesome. And this feeds into what we've been talking about at LongHash for some time, which is the idea of the multi-chain future, right? Everybody wants to set up their own chains, or we have so many different chains, each with their strengths and properties, and how do we bring it all together? And of course, this vision is shared by quite a few projects, and we've seen quite a few attempts actually at between like bridging assets and interchain communication. What I understand that Axelar is different is that there is a concept of fulfilling what we call like internet scale kind of connectivity, right? And that goes back to some of the principles from the founding fathers of like internet connectivity, Cerf and Khan. I know you wrote about these principles before on some of the blogs and how Axelar fulfills these. I would love to just recap some of those and who else is actually achieving these like specifications or principles laid out by Cerf and Khan before.
Yeah, awesome. No, great question. You know, the problem of connectivity across networks of databases, right, is not a new problem, right? Like this is something that academics and engineers have studied for, over 30 years, right? And I think as we started to think about the problem at Axelar, kind of just going back to the roots and understanding what makes a good scalable design that can allow us to connect, hundreds or millions of chains down the line is really going to be fundamental, right? So the basic properties that you need for that are ease of connectivity, for instance, right? So how do you make sure that any chain that wants to have connectivity to all the other chains can be interconnected with very simple interfaces and APIs, right? We have seen certain protocols in the industry that are incredibly complex to connect, right? So for instance, we have things like IBC that runs within the Cosmos ecosystem. It's working quite well for that ecosystem, but when it comes to other types of blockchains, it's really hard and takes a lot of time to extend, right? And so the very core principle is being able to plug and play any blockchain in very simple connectivity model. So that's number one. Two, you have to understand how do you make sure that the liveness and safety properties of these blockchains are actually really, really robust, right? So as an example, if a message as it goes from one blockchain to another is dropped, how do you deal with those properties, right? Who should deal with those properties? What type of a system or protocol should deal with those properties? And so basic principles say, well, retransmission of messages always has to come from the source, right? And the sources, in your case, could be a user, right? Or an application that needs to communicate the message. And so you have various protocols that allow you to facilitate this. And at the very core of it is another third principle that I like to think about is the principle of modularity, right? So intranet and all the protocols that have been built, they have been built in layers. So you have things like transport protocols, right? Think of them as your, highways and airports, right? And air traffic control systems. So those are like transport systems, right? And on top of them, you have various types of, application layer protocols, right? So as an analogy, you can think about application layer protocols are things like, how do I ship a good from one country to another, right? Or how do I ship a package? Or how do I ship, just a letter? And the mechanisms that you use to ship a small item versus a big item versus maybe some type of a fuel are very, very different, right? So you can think of those as application-specific protocols. And so kind of a decomposing the system and deconstructing those layers to really understand what are the rails right? And what are the transport layer protocols and what are the application layer protocols on top of it is really fundamental to continue having a robust, scalable, and a modular design. And so, we have been following some of these very core principles from day one at Axelar, and really kind of pioneering and creating a lot of these blueprints for the ecosystem.
Awesome. And this robust design is, of course, somewhat different from some of the more commonly seen, say, bridges and so on. We've seen some of the pairwise multi-signature kind of bridges, and those have been actually exploited and hacked before. And would you like to just expand a little bit on how Axelar is different on that regard and how the exploits are less possible or much harder?
Yeah, at the very core of it, you have to start with a system that is decentralized. Okay, so what we have seen in the ecosystem over and over again is that systems that are decentralized have diverse validator set, have a lot of participants that may need to be compromised to break that system, and are a lot more robust in practice, right? Every proof of stake system today or proof of work system that you have today have things like not every, but many of them have open consensus mechanism, right? Where many validators can participate and secure those protocols jointly together such that only, a very large fraction of them needs to be compromised in order to break the system, right? And so most of the protocols that you have seen in the industry for interoperability to date have been centralized for all practical reasons. So they're custodian services that typically, take possession of funds as they're going from one chain to another, right? And we have seen over and over in most of the hacks that they get exploited one way or another, from very simple attacks like just a few nodes get compromised, or the entity that runs the servers for the interoperability gets compromised and the keys are leaked, right? And then you have loss of funds as a result. So Axelar, from that perspective, is the only decentralized interoperability network that supports an open and diverse validator set. Anybody can join and participate and help to secure the network jointly. And you have to compromise serving a majority of that system in order to break it down. So yeah, that's the very core principle. And then on top of it, I think very importantly, Axelar is not pairwise, like you mentioned, right? A lot of the bridges in the system have been pairwise, and you can really only scale pairwise connectivity so far, right? If you have 100 chains, and if you need to interconnect them all in a pairwise connection, right? You're looking at kind of a 100 square over 2 types of connections, yeah. Right? So lots of connections will have to be managed, and you as a result is a complexity, right? And the result is cost for everybody to manage all these connections in a very simple way. And so Axelar provides kind of a many-to-many connectivity, meaning that any new ecosystem that's added is automatically interoperable with everything else, right? So in that sense, it's almost like a transportation hub, right? Think of like a New York where, you can come in and from there you can fly to any other, country, in this case, country being served the blockchain in an efficient way. Yeah, and I guess the final thing I'll mention here is that I think the other thing that we're pioneering really for the ecosystem is the notion of general cross-chain composability via general message passing, right? So most of the first generation of interoperability protocols mostly focus about token transfers, right? And token transfers are great, but they only allow you to send A to B, and that's about it, right? In the same way as like Bitcoin as an asset was amazing, but you can only send it and do very, very little programmability with it, right? And then came things like Ethereum that were sort of Turing complete, that allow you to really program functionality in a very universal way, right? And so things like general message passing with Axelar is really a step in that direction and allows you to have this Turing complete composability where you can send from any type of asset to any type of a message to compose your application from one ecosystem to another. And that really enables better experiences and better application integrations for everybody.
Absolutely. And with that, I think the vision comes to then like wanting everybody to rely on this hub, which is then XLR, as you said, to pass the different messages and to then like almost like rely on the decentralization of XLR network itself, right? So that's a spectrum, right? As always, are you happy with the current like level of decentralization with like the validators, with the gateways? Like, is it like robust enough, in your opinion right now to support some of these like cross-chain applications or what else is needed and where would you like to go from a decentralization perspective?
Yeah, it is pretty decentralized right now. I think we have kind of a 45 or close to 50 validators right now across the network. Even in the early days, while we're still kind of in the moment of rolling it out. So we just set like a lower parameter to make sure the system kind of rolls out correctly, but it's a parameter that we're going to keep on increasing, right? That being said, I think we're always going to continue improving decentralization of the system. So a small alpha, but one of the next upgrades on the network, we're going to introduce a very interesting property called quadratic voting. And without, getting into the details of it, the idea is that, you want to make sure that you kind of control how much stake a single validator can accumulate in the network, right? And so we're going to be rolling out a sort of a feature that makes sure that even if a validator has starting to accumulate a lot of stake, their voting power in the consensus protocol for the purpose of this interoperability remains capped in some sense, right? So won't go into the details, but really important property that will allow us to continue increasing the decentralization of the network. And so we're going to continue working, right, on various levels of decentralization. We have a few other plans that we'll kind of be releasing over the coming years. But like you said, it is a spectrum, right? But you have to start with a core design that actually is permissionless and decentralized, right? And then you can increase, number of validators, you can increase, your thresholds, right, to be higher, and so on and so forth. If you don't start with a simple, with the right design, then you're going to be back in square one of just a centralized system.
Makes sense. So often there's kind of a trade-off between like more practicality and then like more conceptual benefits that we need in the longer run. And with that, I think XLR has taken a fairly pragmatic approach, right? Given that we have just gone to market, we have launched, and it's we started in April, if I'm correct. And since then, we've been integrating different networks, like different projects. We'd love to hear from you since launch until now, right? What's the traction been like in terms of like projects and integrations? Please highlight some of your favorite examples as well.
Yeah, I mean, since the launch, I think it's been really amazing, right? It's been, kind of a little over 4 months since we launched the network, but we processed over 1 billion in cross-chain volume, right? Without really focusing on that too much. We connected 16 different networks, everything from Cosmos networks like Osmosis, Cosmos Hub, Secret Network, to a lot of EVM chains like Avalanche, Ethereum, Polygon, Moonbeam, and Polkadot ecosystem, and Binance Smart Chain, right, and a bunch of others. So the list kind of continues growing. The number of integrations continuing to grow, and the early activity is really, really amazing. So yeah, that's kind of the progress to date. What we're working a lot right now with is applications that are building around the stack to really help them build in this cross-chain native way, right? And by leveraging things like general message passing that I mentioned, you can build a next level of user experiences. And so that's really what I'm excited for, to kind of continue building in the ecosystem.
Are there a few early examples of the applications and the use cases, right? Because quite a few are listed on the website, and we've like conceptualized those like with like cross-chain NFTs, cross-chain AMMs, DeFi, so on. Are there any that are like already live or like you think like close to launch?
Yeah, definitely quite a few close to launch, right? Like first applications were really the initial ones that went live were around bridging, which is mostly like moving your tokens, right? And this next wave of applications that we're seeing, I think like the teams are working, and so we'll probably be making their own announcements when they're ready. But everything from kind of cross-chain AMMs, right, to cross-chain NFTs and kind of lending and borrowing applications, right? So just to give you an example, right now, every AMM that's live out there in the market, that's live on a single chain, right? So it has assets on that particular chain, and you can only trade those assets. And so how do you extend those AMMs to be really cross-chain enabled, where any asset can be supported, right, across the ecosystem? In the same way as like in a decentralized exchange, you can have any asset be listed, theoretically, and be traded. In the same way, we want to extend these applications like AMMs. I'm pretty excited about NFT use cases also as well. So something I think we have seen sort of NFT creation phase, right, over the last year, and is going to continue doing so. So it's sort of asset issuance, right? A lot of NFTs are being created. And now I'm seeing a lot of applications that are starting to think, what do we actually do with these NFTs and how do we leverage in them right way, right? So for instance, I have an NFT, but now I want to take a loan against it, right? And maybe in the application which I want to take a loan against it, it actually lives like on a different blockchain, right? So how do you do it with a minimal effort, with minimal interaction? Maybe don't even have to bridge my NFT and things like that. So that's another type of applications, I'm pretty excited about. Yeah, I think wallets are also going to be cross-chain. So I think that's going to change the whole user experience as well. Having a wallet that can interact with any application across the ecosystem is really going to simplify UX and help us onboard more users to the ecosystem.
Absolutely. And it's so exciting that all these are being built today, right? I'm curious, for these early adopters of cross-chain or multi-chain, what are some of the challenges that they're facing right now? And I would presume that when you talk about cross-chain, that we're early days, right? Things like gas prediction, latency, all this. We'd like to hear like some of the real challenges on the ground.
Yeah. So a first example, I would say that we had to solve for some of the early applications. That how do you enable users to pay gas across multiple chains with one click, right? So as an example, if you're sending a transaction from Ethereum and it needs to be executed in application on Avalanche, right? Somebody needs to pay gas for Avalanche, and somebody needs to pay gas on Ethereum, and somebody may need to pay gas on any intermediate chain that kind of a processes the traffic, Axelar being in this case. So how do you allow users to do it with one click, right? And so kind of to address it, we're building things like gas services on top of the network, right? So what do they allow users to do? They allow users to send one transaction and pay to a special contract, right, on the source chain where they send their transaction from. And then their gas is going to be taken and used to relay and pay the gas on all the other interconnected chains, including like Avalanche, and executing the transaction and potentially returning the result all the way back to the user, right? So traditionally, like these blockchains don't have any of these mechanics, right? And even when you think about interoperability protocols, that's not the job of an interoperability protocol to deal with gas, but you have to think about these layers on top of it to, to enable these one-click experiences for the users, right? And then a second example that I like to show is actually how do you monitor the state of these transactions now? Right. So we have built things like explorers that allow us to monitor, Ethereum, Avalanche, Solana, all these individual chains, right? And they're pretty standard. They observe events on that chain and all the transactions, and they display it, right? And then you can go and you can search by your transaction hash and so on and so forth. Now, all of a sudden, you have an interaction of all these, different chains. And so when you're talking about a cross-chain transaction, you have to almost like aggregate the view of multiple of these ecosystems and provide a consistent visibility for both applications and users to say, oh, my transaction is, is still being processed, or it has already been processed, right? Or maybe it's waiting for some finalization rules on my chain and things like that. And so this is, again, something we spend a lot of time on. So we'll have things like, Axelar-Scan, which is an explorer. I think like it's the most powerful cross-chain explorer you'll probably find right now. You can really trace precisely where your transaction is, how long it takes to execute, from one step to the next step. And all of that is also exposed via an SDK and API that applications can integrate with, right? So yeah, I would say a lot of work goes into building these sort of, a couple services for the network to enable these simple experiences. And then I think the final thing that I'll mention here, for a lot of developers, they have to start thinking about very different programming model, right? So traditionally, when they were coding the application on a single chain, they were thinking about atomic operations. Atomic means you send a transaction, it goes through or it doesn't go through, and you'll know it right away as a user, right? In a cross-chain world, you're switching to kind of asynchronous message passing, right? So again, think of an analogy where, you're sending a mail from, one country to another, and it goes on an airplane and your mail gets delivered, right? What happens if there is, you specify a destination address and that destination address actually does not exist, right? In the city where you mail into, or you made a mistake in your postal code, right? And your mail may have to actually be returned. So just like, in the physical systems, we have kind of a ways to dealing with what happens when these kind of transport layers don't work, or you make a mistake as a user. As a developer, you have to think similarly to code your application and say, okay, if the message is not specified correctly by the user, or it cannot be executed on destination chain, you may need to return this package back to the source chain and things like that, right? And so you have to think about asynchronous communication, and you have to architect your application slightly different. And that's where we also kind of spend a lot of time on just educating the developers. Once they realize like the power and what you can do with this message model, the lights open up, right? And they see all the flexibility. But for a lot of especially younger developers in the ecosystem, I would say they, it is a new approach.
Oh yeah, completely new mental models. If you have to build in this like fault tolerance, or what happens if it doesn't get executed, right? Send back,
Exactly,
resend. Yeah, indeed, requires a lot more kind of like education. So, and as you said, you've been improving the lives of the developers very much with some of these like tools and widgets, I would say, with like gases and so on. And on the other hand, we also want to enable like more surface area, right? More potential applications to be built by integrating more chains, right? So we've seen like, for example, Secret Network on Cosmos and like Manta on Polkadot for like privacy features, integrating the smart contract chains in various ecosystems so that we can tap into the various projects while building on top. And like, I'd love to go to some of that kind of future looking integrations as well. Like how do we then increase the value that Axelar as a hub can bring to the developers who are building on top, right? So what are some plans or priorities for integrations? How do you think about it?
Yeah. So kind of, I think, just back to your point, right? I think enabling some of these almost like application-specific chains to talk through the stack really has powerful effects, because it allows those applications to export their functionalities for everybody else in the ecosystem, right? So when it comes to privacy-preserving chains like Manta or Secret Network, by default, they're their own, again, countries that have these privacy preserving properties. And now all of a sudden, by integrating with Axelar, you kind of open up this functionality to everyone else in the ecosystem, right? So, if you want to send a transaction and you want to, do some private computation, you can make a call, like an API call that from any other chain that will be routed to these, hubs, executed in a privacy preserving way and return back to it. And so I think one thing to kind of mention here is that what makes a lot of this actually possible is another kind of a core differentiator of Axelar is that by itself, Axelar is actually a blockchain, right? So what that means is that on Axelar, we can have very sophisticated sort of functionality to process interoperability a lot more efficiently than any other protocol that you see in the market, right? So as an example, we support things like deposits from centralized exchanges to any other chain, right? So how does it work? Traditionally, if you wanted to use a bridging protocol, you have to use MetaMask, okay? And that's about it. And like you send a transaction, that transaction specifies where you want to go, and you have to call a smart contract to like send your token. Now with Axelar, what you can do is you can ask Axelar to create what we call as a portal address, which looks like any other address on an Ethereum chain, and you can send your funds from like Coinbase or Binance directly to this address without having to have MetaMask, without ever having to interact with Ethereum, right? Or having to have gas on Ethereum. And then your asset will be delivered to any chain that you want, like Secret Network, like Osmosis, like Avalanche, and so on and so forth, right? So by having programmability on the network itself, we can extend and make these experiences much easier for the users, that they don't have to have MetaMask. They don't have to have ETH to pay their gas and so on and so forth. It allows applications to have a much wider distribution, right? So instead of only tapping into 30 million MetaMask users, I can tap into 300 million of blockchain users. And by having programmability features sort of at the Axelar to deal with this, routing requests in this case, it allows us to have more and more functionalities. So we're going to continue doing some of this work at the network layer to extending these more sophisticated, features. Because as we get more integrations, especially when it comes to, privacy preserving chains and so on and so forth, how you route there, what types of requests you make there, what types of translation you do of the messages along the way becomes quite important. And, having a blockchain that you can program to do those interoperability requests is incredibly powerful.
Yes. So in terms of integration priorities, right? Given now we have a couple of privacy kind of possibilities already, and smart contract chains, like liquidity focused chains like Osmosis. What is there a particular priority that you are looking at next?
Yeah. I mean, we try to onboard as many chains as possible. That's the reality, right? Like we build a network to be able to onboard, Cosmos chains efficiently. Okay, it's like IBC supported at the consensus by default because we run Tendermint. We programmed an ability to onboard EVM chains. So once you do the testing, once the validator is registered, you run a handful of commands and EVM chains become interoperable with everything else. We have been running kind of a Bitcoin in a test environment for some months now. And, we'll probably, focus on that in the coming quarter or so. And then there's a few kind of one-off integrations that I think we're working through, with chains that have their own kind of a custom consensus mechanisms. But we'll have to wait for announcements.
All right, we have just 1 minute left, as I understand. So let's wrap up with two last quick questions. One is, how can teams get in touch for developers? What kind of programs, what kind of support do we have?
Yeah. The best way for a developer to get in touch is go to docs.axelar.dev. Some of the early, documentation is there. You can understand how to send tokens, how to send messages. Follow on Twitter, right? So it's at axelarcore. You will find links to GitHub, to Discord, and other social channels. We're pretty active on Discord. If you go to some of the developer channels there, ask questions. We're always there to assist and answer any way that we can.
If I may add as well, at LongHash Ventures, we love to invest in cross-chain applications and builders, be it infrastructure applications. So please feel free to reach out to us as well at LongHash VC. Well, just to wrap on a slightly lighter-hearted note, are there any other areas that you are excited about other than cross-chain in Web3 today? Yeah.
I mean, I'm excited by new programming models, right, that are, I think, coming. So in Cosmos, I think I'm quite excited about both what Secret is doing, but also players like Agoric, right? So that they're trying to introduce, JavaScript as a programming language. I think we're seeing a lot of interesting work from some of the sort of Facebook mafia chains, right? Aptos and Mistin with the Move language. So I think those developments are actually quite exciting. At the end of the day, I strongly believe that building in a blockchain stack is going to be simpler than building in a Web2 stack. There's still some work to do that, but that's the ultimate goal. All right. On that note, let's wrap up. Thank you again so much, Sergey, for your time. It's been such a wonderful conversation. Thanks for having me. It was amazing.